Welcome to The Explainer. Today, we're looking at a text many of us think we know, but through a lens that is, well, completely different. We're not talking theology, we're not talking literature. We're talking engineering. Let's dive in.
So first thing, I want you to forget the image of a dusty book sitting on a shelf. The whole framework we're exploring today asks us to see the Quran as a piece of advanced software, an operating system that's designed to boot up and run a system audit on you, the user. The core idea here is that this isn't just a message to be read, it's a mechanism to be run.
And that really gets to the heart of it, right? For centuries, the entire focus has been on interpretation, on exegesis, on finding the meaning. But what if the structure itself, the way it's all put together, the connections, the literal design, is a huge part of the message? Is it just beautiful literature, or is it a precision-engineered architecture?
To even explore this, you have to make a pretty fundamental shift in how you see it. We have to move from viewing the Quran as this passive, static object to seeing it as an active, dynamic, information processing system.
Okay, check out the contrast on this slide because it's key. Traditionally, you have exegesis, which is all about asking, what does this text mean? But this new paradigm, this engineering approach, it asks a totally different question. How is this system built? What are its design rules? One studies the output, the other tries to reverse engineer the source code.
And this image just nails that shift perfectly. On the left, you've got the old paradigm, a book in idle mode, a passive input. But on the right, you have the new paradigm, an active processor running a full system audit. It's the difference between a paper manual and a running application.
So this whole idea has a formal name, the Quranic Engineering Paradigm, or QEP. It's really a framework for studying the Quran as a design system, almost like you'd analyze a complex piece of technology. It's got encoding rules, dependency networks, architectural constraints. The goal isn't to create a new interpretation, but to reconstruct the original design logic.
All right, so if we're going to call this an engineered system, what does its architecture actually look like? This next part takes us under the hood to see the core design that's being proposed here. So according to this paradigm, the whole system operates on a 7-layer stack. It's a lot like the communication protocols that run the internet, actually. It starts at the very bottom, the physical layer. The actual sounds in the script. And it builds all the way up to the top, the ontological layer, which is where the information becomes a lived, experienced reality. And the key is, each layer is totally dependent on the one below it. Now, this is absolutely crucial. In this system, meaning isn't something you can just find and isolate in a single verse. It's not stored there. Instead, meaning is an emergent property. It's computed by the interactions across all 7 layers of the architecture. Think of it like a neural network, where the insight doesn't come from one node, but from the connections between all of them. Okay, so we've talked about the abstract design. Let's get practical. If the Quran really is an operating system, what are its main features? And, maybe more importantly, what are the most common user errors?
So one of its killer features, think of it as the ultimate GPS. In a world where trends and values are constantly shifting and crashing, this system is designed to provide stability control. It gives you a fixed coordinate system. The argument is that this path, it doesn't fluctuate like a volatile market.
But then, you get user errors. The first one is a classic. Error 404, device found, user absent. This is the glitch of majra, which means abandonment. The device is right there, physically present, sitting on the shelf, but its core function is never actually engaged. It's like the user is ghosting the creator's messages.
And next up, a system alert for a major compatibility issue. This is what happens when the signal's clarity is at 100%, but it directly conflicts with the user's ego or their comfort zone. The user ends up rejecting the output, not because it's unclear, but because the truth it's showing them is just, it's uncomfortable. As it says here, it's not a bug in the code, it's a virus in your heart.
And this is a very modern problem, the DDoS attack. The idea is that the source code itself can't be hacked, so instead, opponents just try to jam the frequency with noise. Social media, ridicule, infinite scrolling, distractions. The challenge for the user then becomes lowering that signal-to-noise ratio to become a clear receiver instead of just being part of the jamming signal. This all brings us to what might be the system's most profound engineering property, its integrity. This is the idea that the source code itself is unalterable, that it's unhackable.
The technical term for this is an architectural invariant, but what does that really mean? Well, think of it as a core property of the system's design that is just locked in. It stays constant. So while our interpretations might change over time, the underlying architecture itself doesn't.
And that invariance is what's said to guarantee its stability.
And that stability is demonstrated in what's presented here as a kind of open-source challenge. Humans, and even advanced AI, are challenged to produce a system that has the same semantic depth and the same structural stability. And the result? Null output. Access denied. The argument is that the system's complexity just can't be replicated.
And you see that same immutability right here. A user basically puts in a request for a modded version, a Quran Lite that's customized to fit their lifestyle. And the system's response is just blunt, error, write permission denied. The Prophet himself is described as the interface, you see, not the developer. He can't change the source code.
This quote really just drives the whole point home. It frames the entire system as a form of divine software that is fundamentally incompatible with our human hardware. It suggests we can't compile it, we can't replicate it, no matter how advanced our technology gets.
So when you look at the system's properties, it's like reading its official origin certificate. It says integrity is at 100%, zero noise, a direct stream from the master source. And the argument goes that you can't fabricate it because the informational complexity, the entropy, is just way too high for human hardware to generate from scratch.
And so this is where it all lands. Diagnostics are complete, the software has been verified, but the hardware, that's the user, that's us, our status is pending. The final command turns the whole question back to you. The system is ready, the update is available, the only question left is, will you execute?